There we go. So looking at the title for the talk today, challenges and opportunities for sustainable digitalized production. I know it's quite a mouthful, it's a lot of big keywords there, but I'm going to bring them down into smaller details and ask some more specific questions about how we can use digitalization as a tool to achieve more sustainable production systems. So I really see digitalization as the tool, and what we try to achieve is more environmentally sustainable production systems. So I will focus on environmental sustainability specifically today. Now for the talk, I have broken it down into 4 parts to share with you what we have done recently in our research. So first I will look at the research trends, since we've conducted a number of systematic literature review recently, and we have seen some really interesting trends happening there, some really encouraging ones, and others that are a little bit more worrying. So I will share with you my worries, but also my hopes. Then we will focus on specific challenges around circular economy and eco-efficiency specifically, and try to unpack that and not just stay at the high level of being more sustainable, but actually what does it mean a bit more practically in the operations. And then I will present to you, if I can say that, present to you the 8 propositions that we are suggesting in how digitalization can more systematically support sustainable production systems. And finally, I will close with a research agenda that we have recently submitted to a journal. So both the propositions and research agenda have been submitted recently to a journal, currently under review. So starting with the research trends, I'd really like to look at what is currently is being done on sustainability by looking at the keywords that different researchers are using, but also looking at around those keywords, what do they do in their research? So being as specific as possible when we say, oh, we want to be more sustainable, what does that mean? And the first thing that I have done is just do a quick search to look at the general trends around the topic of sustainability and digitalization. I have put the keywords that I have used for the search on Scopus at the bottom here. And I have also filtered for the field of engineering to make sure that it's really relevant to what we're looking at, although it overlaps a lot with the field of business research and management. So now looking at those trends, I have looked, as I said, digitalization and sustainability as 2 separate trends. And then I have also looked at how much between those samples of articles were overlapping to see how strong sustainable digitalization is. And as you can see with this figure, sustainability research has started a really long time ago. So it's a steady growth over the years. As I said, encouraging trend here. We see more and more research on sustainable production, sustainable manufacturing, or environmentally conscious production manufacturing or green manufacturing. Now looking at digitalization, the trend started a bit later. But it really took off around 2012, 2015, especially with the topic of Industry 4.0, which is a keyword that we started seeing really in 2014, 2015. And we can see there's a massive exponential growth here for that the research in that field. And it has largely overtaken the topic of sustainability since 2017. And if we look at the overlap, so I looked at those 2 samples of literature and how much of it was overlapping, and it's highlighted here in orange. And that's where I have a worry, because the amount of literature on how we can use digitalization to improve production system is increasing really fast. And we can also see the adoption in industry increasing really fast. But thinking about what are the sustainability implications of this application of the technology, I think is not systematically considered. And if we look at the industrial revolutions in the past, so the first, second, and third industrial revolutions, we often heard about those undesirable consequences or unintended consequences that resulted in climate change, in pollution, in various environmental impacts. And what I am worried about is that with this new trend, we don't necessarily see a divergence away from those negative environmental trends. But on the contrary, I'm a little bit worried that we will accelerate a linear economy, that we will accelerate climate change, that we will accelerate our environmental impact. So the argument that we are making is we need to more systematically consider sustainability in how we implement technology. Now, obviously, my search may be a little bit flawed here because I had only keywords that I was really analyzing. But in the next few slides, I will show you in more details using more varied terminology what I have seen. But yeah, so this is encouraging trend in terms of more research on sustainability, a worrying trend in that it looks like at the moment we almost have two competing trends with digitalization and sustainability, and are not well integrated. Now, focusing on eco-efficiency principles, so that's what I usually use as a baseline to really think about what does sustainability from an environmental perspective means in manufacturing, and we can break them down into the 7 guiding principles for eco-efficiency that were created by the World Business Council for Sustainable Development in the 90s. So we know this for a really long time. I have seen different versions of those principles recycled in different formats, including for circular economy, but fundamentally, it's always coming back to those 7 principles. So the first principle is about material intensity, so how much natural resources we need to make goods and services. And goods and services are the vehicle to deliver value to society. So the concept of value, I'll come back to that a bit later, but also reducing the energy intensity. So for those first 2 principles, they're very focused on resource efficiency, how much resources we consume to create a product. The third principle is on toxic dispersion. So this is related to waste and pollution, so the negative environmental impact associated with the process. Then the fourth principle is on recyclability. So thinking about how we can close the loop of material flows. And for this one is focusing mostly on the recycling circular strategy. For the other ones around reuse, repair, remanufacturing, you can see it goes in line with the product durability with the principle 6. And then we have the principle 5, focusing on the sourcing strategies for resources and focusing primarily on renewable, non-toxic, abundant resources, both for material and energy. So I have also bundled keywords around bio-based or bio-inspired for different materials for the sourcing strategy around this principle 5. And finally, the principle 7 is around the service intensity of goods and services. And this goes hand in hand with the servitization trends of product service systems. So again, turning to the literature and looking at how many articles we have seen, looking at both digitalization and those particular principles. So for material intensity, it's actually been quite difficult to identify a clear trend because the keywords we can use here for dematerialization are quite diverse. But what we have seen is for dematerialization, we have a lot of research on materials development, so new materials, so we can achieve the same functionality with less physical materials. It does not necessarily mean that it's more resource efficient, because sometimes those advanced materials still have what we call a large backpack. So you still need to consume a lot of resources to create those high value materials. But we also have trends around miniaturization or multifunctionality or lightweight also. So for example, new material structures or new product structure to reduce the weight of the product. And that would go with this material intensity. So for miniaturization, I think the trends in a precision manufacturing or for lightweight structures, we have additive manufacturing. So all of those new technologies that are usually also around digital manufacturing, I think fits really well there. But it is very difficult to really identify this because of the diversity in keywords being used. Dematerialization is actually rarely used. If I just look at the dematerialization, I found only 2 articles there. So I need to be a bit more broad in those keywords. Energy intensity, however, is a dominant topic. And I think historically, when we look at green manufacturing or environmentally conscious manufacturing, energy has always been a dominant topic. And that's simply for the fact that in manufacturing, we tend to operate within a fairly constrained space where we have already a product that is designed with some certain requirements. And we have also the customer requirements on the other end, and we operate within that constrained space. So I like to see energy as kind of a currency for the conversion of natural resources to meet those requirements. So thinking about how we can increase the energy efficiency in manufacturing is kind of the old eco-efficiency. So big trend here. Then looking at waste reduction, it was also a quite a large trend. So for both of them, it was about 150 articles that I have found. And over 100 of them are really focused on waste reductions in the keywords. And I think naturally we can see a good fit with economic sustainability as well, since waste is usually a waste of resource and therefore a waste of cost, a waste of money. So there's a nice win-win situation. However, for pollution reduction or for toxicity, it was less than a third of the articles tackling this. So I think focusing more on the environmental impact is a little bit more difficult unless we can make a good economic argument to go with this impact reduction. Then turning to recyclability, actually, I was quite surprised to see that the literature on how we can have manufacturing system being part of closed loop systems was actually not a big dominant in the samples of articles we reviewed. So thinking about how manufacturing can be an engine for facilitating circular economy, I think is something we don't speak enough about. If we look at the literature on circular economy, it's mostly focused on product design or business models. There is not that much on the overlap with sustainable production, which was really surprising for us. Then for renewable sources, again, I think this is usually a trend that we see more for the energy sector. But when we look at manufacturing, there may be some mentions about sourcing renewable energy, either on-site or off-site, but actually it was not a big dominant. But thinking about the implications, if we are going to rely on renewable energy sources that may be more fluctuating, thinking about energy storage technologies, these are not necessarily thought about when we think about the design and the development of production systems and shift to lower carbon emissions. So I do not know if that is a problem or if it's really well covered elsewhere, and therefore we don't need to worry about it in manufacturing or production research. I do not know. I'm just telling you what I have observed. Then moving on to the principle 6 with durability. Actually, the topic of remanufacturing is a very strong topic. So for this one, we have seen some pretty good coverage on remanufacturing. But when we look at reuse, repair, or modularity or disassembly of products, this is not something that is as well covered. So yes, for remanufacturing, but maybe less so on thinking about how product durability can be tackled when we think about manufacturing. So what are the implications for disassembly, repair, reuse on how we make products? I think this is something that is not as well covered. And finally, for the service intensity, similar to the first principle, it's a bit difficult to identify the trends here because initially when I did research, I found a lot of articles that had the keywords around services or servitization. But actually looking into more details, we can see that it's quite often articles actually focus on service-oriented architecture for cloud manufacturing, for example. So it's not necessarily servitization of goods and services. So again, here I need to unpack it and do a further analysis to understand how is manufacturing aligning with servitization. And to be honest, I haven't seen that many articles. If we talk about servitization, we see servitization within manufacturing systems. So for example, maintenance, and seeing this as a service, or looking at the collaboration with suppliers of equipment as a service, but not so much on the product servitization side. What does that mean for manufacturing system? Maybe rethinking how we configure or the strategy for manufacturing products, maybe through a more localized or distributed or decentralized manufacturing systems. So again, this is not as dominant a trend. But again, full disclaimer here, I focus really on research that had the keywords around manufacturing and production. And it could be that, again, this topic is better covered on maybe supply chain management or logistics. So there may be other keywords that need to be included here. But really thinking about the implication for how we design and manage manufacturing systems, that is where I don't see as much. So yes, these are the trends related to eco-efficiency and a little bit circular economy. And when I look at the articles, I mostly see, of course, success stories. So I know that when we publish articles around those topics, we tend to have what we call the positive publication bias. Positive bias in our publication. So we tend to only publish success stories. And maybe if we had some struggles or if the case study didn't work so well, we are less likely going to publish. So maybe what we need to do is actually be a little bit more transparent and tell us what is difficult, because the truth is those principles are actually not that mainstream. So it's still isolated cases rather than an industrial norm. So if eco-efficiency and circular economy are so successful, why are they still rare in practice? So that's the big question that I am asking. And I'm wondering if we need to also share also the less success stories. I'm not saying necessarily failures, but maybe things are not as successful as we would like them to be, to understand how we can help companies overcome those challenges. Which brings me to the second section of this presentation around the challenges. So here really focusing on what has been difficult both in our research project, but also looking at the few cases in the literature where they've been talking about challenges or barriers or things that are hindering the adoption of eco-efficiency and circular economy. So once again, just to put things into context, now I have removed the keywords around digitalization in order to look at how production engages with circular economy and sustainability and eco-efficiency, and basically what I call the environmental solutions. So here I'm really looking at what are the environmental solutions available for manufacturing companies. And then I will go back again to digitalization and think about how digitalization can support, because as I mentioned, the overlap is so small. So if I only look at the articles at the overlap of the two, I wouldn't have enough material to work with to understand the challenges. So we've reopened the scope. And just so that we are also on the same page, when I talk about eco-efficiency, I also like to think about it in terms of the efficiency of the production systems by looking at doing more with less as basically an equation. And more means the value that we deliver through the goods and services. So aligning with the principles that I showed before, with less, and that is going to be a lower environmental impact associated with the consumption of natural resources. Yeah. So just to go back to this basic definition, and actually a more complete picture would be this one, where we look at the different phases that are associated with the product life cycle. And of course, production is not necessarily just one box. Usually we have a supplier, so it's much more complex than that. So that would be a much better picture to capture how we are looking at resource efficiency of production systems. And I have also added the different circular flows at the bottom here to map the different circular strategies that manufacturing companies can engage with. Although we have not seen all that much on the topic, I still think it's very important to make them visible and increase the engagement of manufacturing with those circular flows. So in terms of the challenges that we have identified, there was quite a large number. So here I'm just going to highlight the main ones that we felt were really strong. So either because there were a lot of articles about it, or on the contrary, very few articles about it. And I will try to give you also some concrete examples. So the first trend that we have seen is life cycle assessment and also various quantitative indicators for environmental impact as being the dominant tools to assess the environmental performance of manufacturing systems. It's not very surprising. However, when we look at the details of how LCA is being used in manufacturing, due to a lot of uncertainty in other life cycle stages for the product, we've seen that most of the LCAs were gate-to-gate, so a little bit more reductionistic, so not always able to capture any rebound effects or trade-offs that are happening from a life cycle perspective. So a lot of researchers are actually calling for better methods, more suitable for manufacturing companies, or maybe better databases to help them overcome the issues of data accessibility or uncertainty, maybe developing better tools for developing scenarios to understand what are the impacts of decisions we take in manufacturing over the life cycle of the product. So yes, LCA is a dominant tool, but right now I think the way it's being used is only partial, and we are not able to capture the full impact of the full environmental impact of production. The second trend we've seen is that the majority of the articles focus on very efficient forward production. So that means we are still largely focusing on the linear economy. So not that much on how we can close the loop, and also mostly focusing on the direct impact of production. So the on-site environmental impact associated with air emissions or physical waste or toxicity in the manufacturing process. It's not always considering what is the environmental impact from the supplier side or looking at maybe the scope 2 or scope 3 for CO2 emissions. I think it is much more common to look at direct emissions on site and at best energy related CO2 emissions for the energy consumed on site. So again, being able to broaden the scope would be really necessary to fully understand the performance of manufacturing systems. The next two trends, actually I can show both of them at the same time, are about topics that we haven't seen as much, and that's where I had my worries. So we have seen very few cases considering the role of service-based business models or servitization, and what are the implications for manufacturing. So how we are going to adjust manufacturing to fit with that trend, or also how we can have manufacturing as part of closed-loop material flows or closed-loop material systems. So quite often we see that manufacturing will engage only partially with circular economy. Mostly it's going to be thinking about how we design products, that can fit in a circular economy at the end of life. So this is a growing trend. It's not the norm yet, but it's a growing trend. And a few articles also thinking about how do we increase the uptake of recycled material in manufacturing in a more closed loop way. So not just having downcycling or open loop recycling, where maybe some of the waste will go to construction or lower quality applications, but having a more closed loop system where we can retain high value in the materials. And we didn't see that many studies on this. Another thing that we have seen, and I think the credit should go to my co-authors here for many of those trends I should mention. So Arpita, Clarissa, Helena, Kala, and Bjorn were part of the discussion here. So this is not just me. A very interesting trend that we've seen with the topic of environmental sustainability at the leadership level or strategic level in organizations. It can be quite an emotional topic, especially when we talk about climate change or biodiversity. I feel like the leadership will take it at a very emotional level. So really making it so as humans, we need to care. And therefore, sometimes the decision that goes with this can be also quite subjective. So we will go with what feels right, but we are not always able to quantify what would be the impact of those strategic decisions and ensure that the direction that we take at a strategic level is actually going to deliver lower environmental impacts. So what we are calling for here are better methods that are easier to use for decision makers so that they will be able to have some more evidence-based decisions when it comes to reducing the environmental impact of production systems. So kind of reconciling strategic level and operational level, maybe through stronger indicators. And I think a lot of the methods that we see right now are pretty advanced and it can be a barrier to using them in decision making. So life cycle assessment was one of them, but there were other composite methods or mixed methods that required quite high knowledge to use. So I would say myself, I think I would have a hard time using those multi-criteria decision-making methods. So can we develop the right tools to facilitate their use? That is the question that we're posing here. And that will go hand in hand with having this more holistic view of what is the environmental performance of manufacturing. So we can identify what are the long-term benefits, but potentially also the long-term impacts of decisions that we make or the improvement that we make, and capturing potential rebound effects or trade-offs. And this can be across the different dimensions of sustainability, so trade-offs between environmental and economic benefits, or also social benefits, but also trade-offs across the life cycle of the product. So for example, if we improve something in production, does it have a worse impact on the supplier side? Or in many cases, we try to focus mostly on improving the efficiency of a product during use, but sometimes it can mean that we increase the environmental impact in production, but maybe it is worth it if it's going to generate massive improvement during the operational efficiency of the product in use. And that is the case, for example, in aerospace. So maybe the environmental impact in production is slightly higher, but we have a much higher fuel efficiency during the use of the plane. So from a climate perspective, for example, it is very positive. And finally, we also have seen a lot of articles around lean production and lean and green. And many people are proposing that lean and green are largely synergistic. However, it is not systematic. It's not going to be automatic. So we need to have dedicated indicators to ensure that when we do lean improvement or Six Sigma improvement or productivity improvements, we also make sure that we reduce the environmental impact. So yes, they are largely overlapping, largely synergistic, but we also need to have dedicated indicators to make sure it is so. Otherwise, we fall back into these unintended consequences or invisible environmental impacts simply because we haven't measured them. Yes, so these are for the last two key findings that we had, as well as the challenges that were related in how do we make environmental performance more visible so they can be integrated in the decision-making process and in the operations management system. So thinking about how do we optimize our production systems, not just for quality or for utilization of equipment, because OEE, for example, is a great indicator, but how do we ensure that when we increase OEE, we don't actually worsen from an environmental perspective. So putting all of those indicators on the same level, have this as something that is visible to do optimization on all of those different impacts. Then focusing on circular economy, we have done a separate study in relation to an ongoing project on circular economy called Rewind. I'm not going to take you through the slides, so just word of warning, it's a very busy slide, but it's going to be included in the handout, and I invite you to have a look at the paper. But we have identified many more challenges, especially related to circular economy and how production systems can make use of circular economy as a trend and engage and be an engine to further increase the uptake of this concept at an industrial level. We have identified some key challenges, of course, related to product design, but also around process development. And that is where we had quite strong trends around automation, digitalization, by thinking about how we can use that to improve the environmental performance of production system as well. Then around share value, how do we help companies collaborate, maybe around standardization as well, to remove some of the barriers for circular economy, and finally identifying the trade-offs, because being circular does not always mean that you're going to have a lower environmental impact. So yes, as I said, I'm going to put this in the handout. I'm not going to take you through all of those details here, but we have identified many more challenges. And many of these challenges are associated with specific pilots that we had in our Rewind project. And we have made also recommendations for each of those barriers. Yes, so this was for the main findings around challenges related to eco-efficiency and circular economy. And to wrap up a little bit on the research side, we have made 8 propositions in how we see digitalization as a tool that could more systematically support sustainable production systems. And I really highlight this keyword here. We really want to be more systematic in how we align digitalization and sustainability, so we don't see them as competing trends, but as trends that are fully integrated. So the first proposition that we are making is basically that digitalization should systematically support more resource efficient and lower environmental impact in production. That's basically the principles of eco-efficiency. We need to use them as foundational. If a technology does not allow us to go in that direction, I think we should rethink maybe the technology system or how it's going to be implemented, or how we develop safeguards to avoid having any kind of, diverging away from this quest of being more environmentally friendly. The second proposition is the systematic integration and proactive integration of sustainability as a driver of performance. So again, I'm thinking about how do we make environmental performance more visible. So maybe this can be done through having better environmental impact indicators, but also integrating them in environmental, KPI dashboards, for example, in the companies. So we can put them alongside cost, quality, safety, and other indicators that are used for managing the processes. I think environmental impacts should be placed at the same level. The third proposition is around the identification of trade-offs between different dimensions of sustainability. So once again, we can see some good synergies between economic and environmental impacts, especially around resource efficiency and waste, because using more resources or having too much waste usually is also an economic waste. But there may also be some trade-offs, so we need to make that visible. The fourth proposition is around the life cycle perspectives. So again, making things visible, so staying with that theme here, and very much understanding what could be the potential rebound effects across the life cycle of the product. And the main rebound effects that we have seen that usually are invisible are the ones on the supplier side. So we need to figure out how do we bring some better, maybe life cycle databases or developing better scenarios, so we can understand how the decisions we make in production will have an impact also on the supplier side. The fifth proposition is around sustainability assessments. And here we are really pushing on the fact that this needs to be data-informed and fact-based business decisions rather than the ones that are really emotional. I'm not saying the emotional ones are necessarily bad, because I think we also need to have inspiring leaders to push us in the right directions and set up some very ambitious targets. However, I also think that we need to have those science-based targets and make sure that we actually measure the impact of our decisions. So for example, around circular economy or servitization, I think there's a lot of emotional push there, but having a service-based business model or a circular business model do not always generate environmental benefits. So let's put a number of that, and let's try to find the right data and the right information to measure the impact. The sixth proposition is around how digitalization can help us handle the complexity of all of the indicators and the complexity of the performance and how we define performance. And here we are talking about having some hybrid methods for optimization around all of those different factors. And I think now with the big data analytics and a much more advanced analytical power that we can have in our data management systems, I think we should be able to handle that complexity really well. So I feel like we are removing a little bit this barrier of complexity is what is challenging us to optimize our production systems, accounting for so many different things. I really think we have the tools and methods to do that. We just need to bring the right indicators, the right data to the table. Then the seventh proposition is around the integration of sustainability consideration as part of well-established management systems. So going back to Lean and Six Sigma or other well-established production operations management systems that we see companies using already for multiple decades. So we need to ensure that we integrate things as part of those approaches rather than develop a separate trend. So the argument we make here is that sustainability or eco-efficiency or environmental performance are not separate from the core management systems. They need to be integrated. So more often than not, what we see is, okay, we will first optimize our production system based on the more traditional indicators, and sustainability comes later on. So we will measure the environmental impact, and then we will report it and maybe think about how we remediate. It's non-integrated as part of the core management system. And finally, for the eighth proposition, we are making the argument that digitalization should also support the shift to more circular and service-based business models, so shifting to a circular economy. And again, this is the trend that we didn't see as strongly in the chapter. So it's not so clear how we can do that, but we've seen a few articles looking at digitalization and circular economy and how this can be facilitated. So I think it's quite interesting to watch out this space, but it's not yet mainstream. So I see a few names in the attendance list today. I know we have some researchers in that space, so I think it is great to have you here. And I look forward to having the discussions with you very shortly. So just to close up with this presentation, I promised you that we would have a research agenda. So I'm just going to show you the 4 research themes that we have identified. And the first one is the one where we place ourselves mostly, the most strongly with the 8 propositions that I showed before. So the first research theme is around digital environmental impact analysis. So having really data, not necessarily data driven, but I would say data supported or data informed systems or methods or approaches to help us integrate environmental information as part of decision-making processes or operations management systems. The second research theme is around sustainable cyber physical systems. So here we are thinking more about the infrastructure or the technology, or how do you select the right technology to support environmental sustainability. And we have identified different threads here. So there's one around communication technology, and that can be just conveying the information, but it can also be around knowledge management that links to the third theme here, about how do you train people in order to use technologies in a way that aligns with environmental principles. And finally, we have the fourth research theme that is around ethical data management and cybersecurity. So this is not a thing that we have expanded a lot on, but we know that these are big prerequisites in order to facilitate digitalization in an ethical and safe manner. So we have also integrated this in our research agenda as a fourth theme. Yes, so right now, just to talk a little bit about the next step for the research in our group, we are going to go further with this idea of thinking about how we can use digitalization or data-informed approaches to support those 7 sustainability principles or eco-efficiency principles. And the big question that we are asking, can Industry 4.0 help us achieve this? And based on what we can see, the answer is yes, it can. But the question is, how do we make sure that we do it systematically? That is where we have a big question. So we are currently doing a pre-study on a project called FREED, for factory resource and energy efficiency through digitalization. And we will prepare a follow-up project with companies to try to answer those questions. How do we make this more systematic? So how do we use environmental data to drive environmental performance of production systems? So that was my talk for today, to talk about sustainable digitalized production systems. and where do we see the main research trends, the challenges, and where do we need to push the acceleration pedal on to address these issues. Yes, I always like to show a wonderful list of publications that we've done with our research group and many of our colleagues. So a lot of collaboration going on here on how we can increase the environmental sustainability of production systems. So a big thank you to all of our collaborators. And that is it for me today. I think we can open the Q&A.